This is a video from the EdExcel P3, Chapter 7, Exercise 7A. We're going to do number 1A to start. So this chapter in P3 deals with the sorts of problems that you have to know how to do in P3 integration. So immediately we just put our indication that we're integrating. So we're integrating this function with respect to x. So 5 over x, I'm already going to just change that to 5x to the minus 1. This is easier to work with. And it will be 2x to the minus 2 and dx. So this is integrate this function to with respect to x. Okay, so P3. First thing, notice that if you have a minus 1, so minus 1, we can't use the chain rule the way that we would usually do. Just quickly to demonstrate in this first video how that would work out. So if I wanted to integrate this. So if you integrate, you first plus 1, and then you divide by this new number. Okay. So let's see what would happen is I end up having a 0 over there, and then I'm dividing by 0. So straight away, you can see that that's not going to work out. That is not going to work out. So plan B is when we have questions in this form, 5 over x, and this is a 1. Okay, not when it's higher than a 1, but if it's a 1. So if we had, for example, that our y was equal to 5 over x, then if we want to integrate our y, integrate 5 over x is going to be the numerator times ln of the absolute value of x. Now, this just takes care of if it's negative or positive. Mostly, you can immediately switch this to brackets later, but in the beginning, it's useful to just keep those absolute values there. So that's how we deal with the -1 exponent and not have a denominator of 0. Okay, so we'll get to that in order. So sec squared x is from our list in the textbook. It can immediately go to tan x. So this a value, I call it an a value. The constant that's in the front can just be brought down. So we have 3. Sec squared x integrates nicely to tan x. We've dealt with the 5, so we know the a value can just be brought down, and it's going to be ln of the absolute value of the denominator. Now, the third term in this function, we can use the normal chain rule on this one because it's a -2. So in order to use the normal chain rule in this order, we're integrating now. So we plus 1, and then we divide it by the new amount. Okay, so it'll be 2, bring down that a value, the 2, and -2 plus 1 is x to the power of -1. And that's all divided by -2 plus 1, which is -1. So just check that twice. And this is indefinite, so there's no x values are given. So therefore, it's a plus c. Okay, I think that concludes our question 1A. I just want to make it a little bit neater for you. Generally, you want your answer in positive exponent form. So all of this is good. The only thing that we need to clean up is this third term. So -2 over -1 is just, 2 over -1 is just -2. And this will be over x to the power of 1. So negative x on the numerator is x in the denominator. And that is your final answer. Okay, number B, we have an E. So we're going to be integrating E. We're going to be integrating a sine function. And then we have one that looks very familiar, just 2x3 to the power of 3. So let's take a look at what happens with the E function when we integrate. So we're integrating this whole thing with respect to x. So for E functions, when you integrate them, usually if you had some sort of function e to the power of x, then if you integrate it, to integrate y, then integrate of e to the power of x is just going to be e to the power of x. So nothing changes. A couple of things to note. For this particular one, we don't have to worry about a function in a function because the function is just x. So it would be times by the first derivative of whatever was inside there. Okay. And in this case, that would be 1. This doesn't affect us. You bring down the constant. So we would have, if this was a 5, we have 5. All right. So E functions stay the same. Special property of E is the first derivative is exactly the same as the original function. So that sorts out the first term. The second term is minus 4 sine x. Well, sine x goes to negative cos x. When you're integrating, sine x goes to negative cos x. So just to see the middle step there. And for the third term, we can just do our usual plus 1 and divide by the new 3 plus 1, which is 4. So I'll put the middle step in with 2x 4 over 4. Don't forget plus c. So let's just simplify this a little bit. Our final indefinite integral, which has no, we don't know our x values, so we leave the c there. Minus 4 times minus cos is actually plus. And 2 over 4 cancel out to being 1 over 2. So we end up with x to the power of 4 over 2 plus c. Okay. For number C, nothing much to talk about except this, what happens with this constant. So take a look at ways we can deal with this constant. So we're integrating sine x minus cos x plus, okay. So for number C, I'm just looking at the mark scheme. What they've done is they've times the constant in. So I'll first do it that way. So if we times the constant in, you end up with 2 sine x minus 2 cos x plus 2x. And quickly, if we integrate this all with respect to x, so just to see what would happen, sine x goes to negative cos, so it'll be negative 2 cos x. Cos x, negative cos x would go to the same sign, so negative 2 sine x, and 2x to the power of 1. Remember that we're integrating, so plus 1 over 2. So that's going to be 2x squared over 2. So the 2's would cancel out. That becomes a 2, and you just end up with x squared. Okay, so don't forget the plus c. It's indefinite. That's perfectly fine. That's perfectly fine. I just want to see, because later on, I do this slightly differently. So, oopsie. If we were to take that constant out, let's see what happens. So normally when I have a constant like this, I put it outside the integral. Like this. This is the same thing. So if we integrate this, we're going to have 2. Our integrand is equal to 2. And sine goes to negative cos. Negative cos goes to negative sine. Stays the same sign. And we have x1 plus 1 is 2, so x squared. And obviously, your last step would be to times that 2 in, which will give us, it should give us the same. Oh, this should be over 2. It should give us the same answer. So just to take a look at different ways of approaching these, this will make it easier with the harder questions. Okay. Number D, just to look at, we want to integrate 3 sectan. Sectan, just this sec x tan x, sorry, becomes straight away sec x when you integrate it. So that's also, this is just memorizable. And bring down the a value of 3. And then we had, here we have our ln situation, because it's, oopsie. What am I doing today? Okay. So we bring that a value. So we've covered this in the previous question. Don't forget the plus c. So not too much time on this one, just a memorizable formula for that. Just to quickly show this in the video, this comes out of the P3 textbook. So just to see, here was the sectan, and I think we've used we used this one as well so far. So this is the list. I suggest that you commit this to memory. It will really help you going forward with your exam. Taking a look at the rest of question 1A, I see that actually the rest can all be taken care of with that list I just shared. So I'm going to conclude 7A question 1 with just those few examples. Okay.